Hi, everyone. Good morning. Thank you for coming to my session on Think Inside the Box. So I'm going to talk about the technical details on the first observed in the wide abuse of Windows Sandbox in some targeted attacks. Okay. So let me briefly introduce about me. So I'm Hiroaki Hara, and unfortunately, I couldn't get the badge due to the system issue, but please trust me, I'm a speaker. So I'm Hiroaki Hara, and staff engineer at the Trend Micro. So I've been working over 10 years in this cybersecurity industry, specializing in the intelligence and malware analysis, and also incident response. So I have presented at the several security conferences, but this is very first time to have a presentation at the Black Hat Asia. So this is exactly the place I dream of, but I never imagined that I would have a presentation in the very first slot. So I'm kind of super excited. Okay, so let me introduce about the main topic of this presentation, just in case if you misunderstand it. So this presentation is not about anti-sandbox. This is about anti-EDR or EPP with sandbox. So if you're expecting some anti-sandbox techniques, I'm sorry, this is not for you. Okay, so but before explaining about the technical details, let me introduce about the third actor behind this campaign. So we believe Earth Kasha has been conducting the campaign that I'm going to describe. Earth Kasha is the name of the China-aligned espionage-motivated threat actor targeting East Asia since 2017, at least. So they are targeting governments and political organizations and research institutes, think tanks, and researchers in Japan and Taiwan. But we have observed some small amount of the victims in India as well. So regarding the image on the right-hand side, a lot of people ask me about what is Kasha. So I put the image of that. So Kasha is a legendary creature in Japan, meaning some beacon on fire. So, but I just randomly pick up this name for this third actor. So there's no context, there's no meaning. So please don't ask me about this same question. So just in case if you're interested in. Okay, so actually our Earth Kasha is not a new third actor. They have a long history. So we believe Earth Kasha is a part of APT10 umbrella, which is a broader concept of the threat actor grouping, including APT10 itself. So APT10 is also another China-aligned threat actor, active since at least 2006. But now APT10 is getting more huge group and conducting several campaigns with the different motivations. For example, on Earth Tensha conducted espionage and also financially motivated campaign during 2020 and 2021. On the other hand, Earth Kasha has been focusing on espionage campaign for a long time. So we clustered these related groups into our APT10 umbrella, but today I'm going to focus on the espionage campaign, Earth Kasha. Okay, so let me briefly introduce on the campaign history of Earth Kasha. So in 2017, they conducted a spear phishing campaign targeting Japan using their Ono backdoor. And in 2019, they still are conducting a spear phishing campaign targeting Japan, but they changed their backdoor into load info. So this campaign goes to 4 years. And in 2023, they changed their TTPs on initial access into exploiting public-facing applications, such as exploiting SSL VPN or file storage servers, something. And they expanded their victims, including Taiwan and also India. And they added some new arsenal, a new backdoor, noob door into their arsenal. And in 2024, they shifted their TTPs again into spear phishing. They still targeting Japan and Taiwan, and the Ono backdoor back to their arsenal in this campaign. And this spear phishing campaign is still going on even in 2025. Okay, so let's focus on the recent campaign. So for the initial access, they deliver a spear phishing email embedding OneDrive link that leads to download the zip file containing a malicious dropper, which we called roaming mouse. The roaming mouse drops the first stage backdoor components and installed into the system. So the adversary investigated the machine through the backdoor commands, and if they are verify that the machine is worth to investigate more, so they install the second stage backdoor noob door. And we observed the abuse of Windows Sandbox during installing noob door in this campaign. So now let's move on to the Windows Sandbox topics. So before describing the details about the abuse, so let's review the basics of the Windows Sandbox first. So Windows Sandbox is an isolated desktop environment to safely run untrusted Windows application using hypervisor-based virtualization technology. So Windows Sandbox offers several key features. The one is the battery included. So you don't need to install any VM software, or you don't need to download VHD on usage. And second is a disposal. So it's not designed for persistence, so you can run a same and clean environment on every single execution. And the third one is a lightweight. So you can launch Sandbox within a few seconds. So Windows Sandbox is designed to are easy to use and easy to install by design. And another interesting feature of the Windows Sandbox is that you can configure the settings of the Windows Sandbox environment by defining the WSB file. The WSB file is an XML formed configuration file for Windows Sandbox, as this image shows. So you can configure a lot of things in WSB. So let me introduce some couple of important features in this configuration. The first one is networking. So you can enable or disable network access within the Sandbox. And the second one is the mapped folders. You can define share folders from the host with some permission. So if you set the read-only as false, so meaning that the folder is writable from the Sandbox. And third one is logon command. So you can define a command to execute when Windows Sandbox starts. So this is supposed to be used for installation scripts or resolving some dependencies on launching. And now we understand the basics of the Windows Sandbox, but how about the visibility from the endpoint security measures such as EPP or EDR? So as you can see this image, so EPP is not installed within the Sandbox, even though the Windows security is running in the host. So I tested with some EDR products, including our products as well, and I also confirmed that the same results. So it seems Windows Sandbox is designed not to be affected by the software installed on the host, even though it's security products. So this is a pretty good chance for the adversaries to hide their malicious activities by abusing Windows Sandbox. So why not abuse Windows Sandbox for defense evasion? But to be fair, abuse of virtualization technology for defense evasion is not an entirely new idea. Project Zero and Deep Instinct has already described about the possibility of the abuse of the virtualization technology, such as containers. But the abuse of the Windows Sandbox in the real-world attack is the first observation in this campaign. So I'm going to introduce about the real-world abuse of Windows Sandbox. So here's the overview of the infection chain to install the noob door using a Windows Sandbox. So let's dig it step by step. Okay, if you want to take a photo, you can take now. Okay. Okay. So for the first step, the adversary drops some components on the host through the first stage backdoor channel. There's three components. One is a batch file. The another one is a PEM file. The third one is a password-protected raw archive on the host. So let's see how these three components can be used. And the adversary registers the Windows Sandbox application as a scheduled task with the system account. So this XML file shows the information about the created scheduled tasks. So the account is system, and Windows application is registered to be executed in the tasks. Okay, so what's happening behind this? So why did the adversary use system for the scheduled task? So here's a trick. Since Windows Sandbox is basically our desktop application, so you can hide a UI by launching Sandbox with a different user's context. So as this image shows, I created a simple WSP file to execute a whoami command on the launching Windows Sandbox, and it creates text file in the shared folders. Then I executed Windows Sandbox with the custom WSP file configuration as a system via schedule task command. But we couldn't see any UI on launching because the Windows Sandbox was running under context of the system, which is not visible from the current user because I didn't run this on OS under the system context. So this is kind of core trick of the Windows Sandbox abuse. So let's examine the WSP file next. So it enables the network from the guest for the CNC communication, and it maps the user folder of the host with the read-write permission, which means that guest can read and write any arbitrary data on the user's folder, so including documents, downloads folders, which may include some sensitive data. So then it runs the batch file within the Sandbox guest as our launching command. So let's see what the batch file is designed for. So it decodes the PEM file, the msiexec.txt, by using satutil and save as msiexec.exe, which actually turns to be our WinRAR command line tool. So then it extracts the payload components compressed within the password-protected RAR archive by using the hard-coded password and also the decoded WinRAR command line tool. Then it executes launcher scripts on msiexec.cmd, which is extracted from the password-protected archive. So let's see what the msiexec.cmd is designed for. So this is actually an installer script for the final stage backdoor, loop door. So it renames and moves components to some specific folder within Sandbox and registers the loader of the loop door as a scheduled task. And now they finally achieved to install the payload only within the Sandbox environment. So let me briefly wrap up on the tricks used in this attack. So adversary executed a Windows Sandbox with our system account to hide a UI, and they granted a read-write permission from the Sandbox to the host machine to access on arbitrary data, including some sensitive data from Sandbox environment. And they also utilized the password-protected archive containing some payload components and expanded them only within the Sandbox. So through this techniques, the adversary achieved to execute a payload only within the Sandbox without being affected by the EDR or EPP on the host. Okay, so now we understand on how it works. So now let's think about how we can detect it. So regarding the countermeasures and our forensic approaches for usage of Windows Sandbox, Itochu and Japan NPA have already published a very good documents, so you can also refer them. But for this presentation, I'm going to focus more on how to find a suspicious abuse of Windows Sandbox for threat hunting. Okay, so before writing the detection rules, let's see how Windows Sandbox actually works. So on Windows Sandbox.exe will be the entry point, and this our application have a responsibility to read WSP file and invoke another service, which name is Container Service Manager over our PC. And this service is responsible for set up the base layer of the sandbox and also analyze the given WSP configuration. And this service also invoke another service, Hyper-V host compute service and over RPC. And it also have a responsibility to create a container based on the given configuration and run and orchestrate the worker processes. So this service launches the final process on wp.exe. This is actually worker process for Windows Sandbox. So this is responsible for controlling the guest sandbox and also loading some required guest components. So this is how it works. So interestingly, Microsoft recently introduced another entry point for Windows Sandbox, WSP.exe. So this is a newly introduced command line tools for Windows Sandbox since Windows 11 version 24H2. So it offers several commands to manipulate Windows Sandbox from command line, such as start or list or connect or exec and also stop. And more interestingly, our WSP stat command has some arguments on config which can be used to define our inline configuration. So this feature offers fully fileless execution and also a hidden UI even in the current user session. So you don't need to use another users to hide the UI of the Windows Sandbox by using WSP.exe. So as you can see this image, you can execute a Windows Sandbox without UI from the command line. So this could be another very good chance for adversary to abuse. So I wrote two different Sigma rules to detect suspicious Windows Sandbox execution. On the left-hand side, it's designed to detect the Windows Sandbox execution on the system context, because which is potentially used for hiding UI. No one wants to, execute a Windows Sandbox with the system privilege. So on the right-hand side, it's designed to detect the WSP.exe execution with the config arguments, including logon commands. But the level of this rule is set as low because it's not necessarily malicious, and there could be some legitimate usage. So I think these kind of two Sigma rules can be used for to find some suspicious execution of the Windows Sandbox. And regarding the prevention, so there's no option to disallow the execution of Windows Sandbox, but still have some group policy settings to disallow some feature of Windows Sandbox. The one you can configure to disallow mapping folders and also networking capabilities of the Windows Sandbox. So this is not a perfect solution, but I think this is still worth to consider it. Okay, and it should be also noted that there's another detection chance for memory scanning. So Windows Sandbox has a process image to manage CPU resources and memory, the resources for guest sandboxes. For Windows 10, the name of the process is vmmem, and for the Windows 11, the name of the process will be vmm sandbox. So interestingly, the memory space of the guest sandbox is exposed onto the host through these process images. So by scanning as you can see this image, I could successfully detect the Mimikatz execution within the sandbox by scanning the VMM sandbox from the host. So if your EPP or EDR supports memory scanning, it's a good chance to detect the malicious activity even within the sandbox. Okay, so let's move on to the conclusion. So adversary always think outside the box, as we described here. But after investigation, we confirmed that there's a lot of chance to detect them. Okay, so what's next? So this type of TTP will be increasing in near future. Maybe yes. So besides the Windows, on Unix or Linux systems are more container friendly. which means they are very good targets. So better to think about how to monitor the suspicious usage of the containers in your environment. And also, the developers can also be another easy targets because they use containers in their daily job. And actually, container abuse has been already reported in the attack against Bybit in this year. Based on the reports, the adversary asked the developers to execute on the Docker project on your desktop. So this is already in the wild. And also, some third actor has been actively targeting developers, such as contagious interview campaign by North Korean actors. So developers should be aware of this kind of TTPs. So my last message, so including our developers and researchers, everyone should be aware of the cutting edge TTPs by the adversaries and get fully prepared before it happens. Okay, so thank you for listening. If you have any questions, just feel free to ask me. Okay. Take your time. Okay, if there's no question, okay. This on campaign, you mean, or TTP? Actually, we investigated the infected machine through digital forensics. So every component is, located in the victim machine. So I found it, and also the victim machine has installed some EDR or APP. So we could have found some potential executed commands by the third actors. So this is how we, figure it out. Okay. Okay. Oh, right. How would the hacker go? Sir, how will the hacker go after Windows Sandbox? How will that how we before using after this recap. So after we see what's already mentioned on glossary are shared on users folders on the host. So on adversary can access to this one. So adversary can access to the users folders from the sandbox. So actually, we couldn't get any actual evidence that they steal some information, but they may have access to some sensitive data from the sandbox and steal some sensitive document or something. Because I think that's why they map the users folder from the sandbox guest, I guess. So am I addressing your concern? Mm-hmm. Mm-hmm. Actually, yes. As I said, I don't have any, actual evidence, but they may access to some sensitive data because the targets for this incident is kind of researchers, and that they have tons of sensitive data for maybe interesting for the third actors. So they may want to access those kind of data. So I guess they may access to that kind of information. Okay. Anything else? Yeah. Good question. Actually, yes. I also sometimes monitor some feedback from the customers, but I think Windows Sandbox is not very popular nowadays still. But Microsoft is encouraged to use the Windows Sandbox because they are trying to make it easy to use. So I think the Windows Sandbox is getting more popular in the near futures. But yes, the reality nowadays not very so popular, I guess. Any other questions? Okay, so but if you have any other question, just reach out to me. I can answer as much as possible. So thank you for coming and listening. Thank you. Have a good day.